Good evening. This is Dr. John Bennett, broadcasting for InternetMedicine.com. Tonight we're interviewing John Hewitt, a medical writer from Philadelphia, who has written an article, everything you wanted to know about mitochondrial mutations, but we're afraid to ask. John's going to run through the article, and then we're going to ask some questions along with a couple of panelists, Roxanne Davenport and Scott Scowcroft. First, we'll introduce the panel, and then we'll go from there. Okay. Good evening, Roxanne.
Hi. I'm Roxanne.
Okay. Go ahead. Roxanne
Davenport. I worked for a reproductive endocrinologist doing ultrasound, so I'm interested to hear your article.
Very good. Welcome, Roxanne. And Scott, could you introduce yourself, please?
Hi, greetings, and very happy and honored to be in the panel or the film strip this evening. And I am the Scott in the Scott treatment, which takes Hangouts on air similar to this and then repackages the videos in different formats.
Very good, and too bad about the Seattle football team.
Yes. Thank you for reminding us.
Okay. Okay. Welcome, John. It's all yours.
All right.
I'll screen share the article. I'll screen share the article right now, and you can run through it if you'd like. Here we go. Okay.
All right.
There we go.
All right. This is an article I wrote last week about mutations in mitochondrial DNA, and at the time I didn't know that there was legislation at play at the House of Commons in England about this very issue, and it just so happens I published it and heard later that day that the so-called three-parent embryo had been approved. And a lot of people don't like that term. I guess people think of it's like a three-headed baby or something. But really no offense is meant, and hopefully not anyone is offended by me using that term. I just heard about people getting upset later. But it just is an article about potential concerns when you take a nucleus and introduce foreign mitochondria to it. Conventional wisdom is that we really don't know what's going on, and the people more or less pushing the issue are showing images of sick children and saying, look, this sick child could have been prevented but for mitochondrial transfer. And when you really look at the issue, you can see that there's a lot of potential problems, like compatibility of the mitochondria with the nuclear DNA, what they call heteroplasmic mitochondria, when you have mitochondria with different genes in them, essentially. When the egg is made, a lot of times different eggs will have different mitochondria, and the same egg will have different mitochondria. And a lot of experiments have shown that different organs that have mitochondria have a lot of problems. A lot of these studies have been done in rodents, and they've been pointed out by some researchers, but in passing this new legislation, all that's been completely ignored. And I'm just kind of surprised at the way it all played out. It looks like they're going to go ahead with these so-called three-parent embryos. So if anyone has any specific questions, I didn't prepare for this little chat here, so it might be better if people have questions, and I can try to answer them from what little research I had done in preparing the article.
Nobody.
Go ahead, Scott.
Well, I was just going to say, nobody better to answer questions about this than you, because you've been doing the research and you wrote the article about it. And I'm not sure if I'm talking out of school, John, but I'm going to start off the conversation by asking the question: What, as I understand it, there's legislation or legislature, Parliament that was addressing this. What is it that how is it that it's politicians who are making a decision about this? Doesn't that feel a little bit odd?
Well, yeah, I'm sure they're informed by the medical community, but ultimately it's a law. I mean, I guess in the United States it'd be the FDA would have a say, and various other government groups, but ultimately it has to be approved by the government before the clinics go ahead and do it. I mean, the women that have the disorders are calling for it, and with good reason. But the research says, well, we should maybe step back and look at it closer.
So is this something that's been simmering for a long time, and it's only just now?
That's my impression. Yeah, it's been an issue for a while, and now it's just becoming feasible to actually go ahead and do it.
Okay, we're joined by Dr. Kim from Korea. Good evening, Dr. Kim. Oh, that's a Daffy Duck imitation. Okay, Dr. Kim, I think you're going to have to go out again and come back. Your audio is having problems again. Just go out and come back, okay? Okay, you know, John, one remark I want to make why it's in front of the House of Commons is because I think it's a funding. Isn't it a funding issue over there? And they vote on it because it probably involves a lot of money, right? Is that part of it? You think?
Yeah, I would imagine that's a big part of it, but I really don't know much about those particulars of it.
How much research has been done in this country with mitochondrial DNA?
Like I said, I think in rodents a lot, in primates and humans probably not so much.
Oh, okay.
Only recently that this whole idea of heteroplasmy, having a mitochondria with either different what they call nucleoids of DNA as a result of fusion with neighboring mitochondria, or just completely different mitochondria. Just the potluck of whatever recombination occurred when that egg was developing.
Well, theoretically, it sounds like if it worked, it would be a lot simpler than the normal DNA. Is that a thought of yours too?
It's certainly simpler. I mean,
you said 13 genes, right?
Yeah, most of them are actually transfer RNAs, so that's 22 right there. Then you're left with just 13 subunit proteins for key respiratory proteins.
Right.
And one thing I point, you say it's actually if you multiply that genome, say 16,000 bases in length, times, say 10 nucleoids per mitochondria, times 10 or 100,000 mitochondria per egg, that's a lot of DNA. Even though it's highly duplicated, it's dispersed in key locations throughout the egg, and it actually controls a lot of the cytoplasmic processes. That's basically what people are finding out.
Right. That's I can remember in medical school they call the mitochondria the powerhouse of the cell, the energy center. Apart from, but I had no idea it would have a role in DNA.
Yeah, I mean, the respiratory subunits provide energy, and having those units regulated spatially and temporally is key. But most of the genes in mitochondria are actually acquired from the nucleus throughout the life cycle of the cell. So there's hundreds to 1,000 or so genes, or proteins rather, that are imported to the mitochondria just for it to function. So the mitochondria does all kinds of other things, steroidogenesis, fatty acid metabolism, amino acid metabolism, all kinds of things. So they're just like little spatial packets of control that the cell dispenses to where it needs them.
Whenever I think of mitochondria, I think ATP. ATP, the basic power source of the cell. But I don't think it has anything to do with this discussion. I'm sorry about to throw a wrench in there.
Well, that's certainly what everybody learns, yeah. A lot more to it when it comes to actually doing transfers and, basically a transplant.
Oh, okay. So what is your feeling, John, about the future of this type of research?
I'd be the last person to tell a woman that wants to have a child with a genetic disorder not to do it.
Oh, okay. So really, so that's where the clinical use would come into play? That would be a possible scenario?
Yeah, but I'd also be the last person to say go ahead with it, blindly.
Right. But that's one area. That's one area which will be investigated, right?
Mm-hmm.
Whether or not they can tell prenatal counseling.
Yeah, right now there is no treatment. It's just selection and identify. If you have a problem, then you can have the child or have an abortion.
Right, right.
So that's not.
Well, I can see why that would be a very, sticky area ethically.
Yeah.
And why it would mobilize people to say, wait a minute, you're pushing the edge there. So, and I'm just going to make a comment generally. The field of genomics needs education, I'm a doctor and I know very little about genomics. In fact, I can speak for most doctors; they know very little about genomics, and we need a ton of education before we start giving advice, especially to, prenatally. I mean, that's a very sensitive area. So I bet you we're pretty far from anything happening there.
Yeah, but the issue of the education is relevant in vaccines. All of a sudden, it's just a huge issue overnight, and people really don't know what they're talking about. And it's a political issue now.
Yeah, that is a huge issue. It just came up in the last 3 months, it seems.
Does anyone know or do much with cord blood from the umbilical cord? Instead of, you could use the child's cord blood for any of the family members to see what they could do instead of having more donors. Could it be taking from the cord blood somehow like that, if it's saved and frozen?
As a source of mitochondria?
Yeah.
Not right now. The technology depends on having an egg. The two two procedures have names like metaphase 2 spindle transfer, and I think it's already fertilized there, and pronuclear transfer, where it's first taken out and then transplanted to mitochondria and then re-injected. Okay. So the cord blood would have to be able to produce an egg. Well,
I mean, I didn't know about maybe one day with the genes somehow.
Yeah, if you could harvest mitochondria and individually put them into the egg, certainly, yeah. Or gene editing. People don't have good techniques for going in and editing individual genes in mitochondria yet. But there's certainly those techniques for nuclear gene editing that could potentially, fix or repair faulty mitochondria. But a lot of problem is identifying a single fault or polymorphism isn't the problem. It's when you have these multiple benign polymorphisms come together, and then you also have within the same mitochondrial genome, and then you have different mitochondria coming together that are squabbling in a sense with each other, fusing and undergoing fissioning all the time, and we don't know the reason behind it.
John, where in the world is this type of research being taken, besides England? Is England a big center of this type of research? They just happen to be the first one that published something, or do you know any other areas of the world that's doing this? Japan?
Yeah, I don't know. There's a big article the other day in Nature about this very issue.
Okay.
And I guess Go To magazine, I breezed through the article and was not impressed by the approach that they took and the outcome, but they mentioned a few researchers that have been at it for a while, and they may very well be from England. I don't recall.
Okay.
Certainly, the researchers that developed the technology are probably the ones that are driving the political issues, I would guess.
Okay. What sources? I hope I'm not prying into your secrets, but what sources do you get to research this type of area of genomics? Do you just kind of Google the term and look at other papers that are written? How does one go about doing that?
Yeah, I just read a lot of basic cell biology that comes out in just the current releases from the major journals.
Okay.
And just understand some basic principles of mitochondria from them, and then just look at more specific journals. Like for this article, there happened to be a special issue in a reproduction journal that came out that was just devoted to this one issue, and I just used that as a source to make some speculative comments and tie in with some older research.
Okay.
So people who want to read your article, what instructions can you give them so that they can find it to find out what the latest is and what you had to write about it?
It's probably in your bibliography, right, John?
Well, the places I write for don't really have a bibliography other than a single link for the major reference article, but I have maybe articles. So yeah, there's links in there you can trace back through different mitochondria.
Okay, very good, John. Now, I'm going to ask Dr. Kim to try to get him involved. Dr. Kim, can you hear me okay? Oh, I guess not.
Looks frozen.
Well, Daffy Duck again. Okay. Well, okay, Dr. Kim, we'll catch you later. Anyways, John, I'd like to thank you for pinch hitting tonight and giving us a presentation. And you're welcome to present any papers that you write. And actually to have more hangouts, even on this article, if you want to involve people that may be involved in that area of research from wherever. They might welcome it, and maybe you can send this video to them to show what it's like.
Okay,
so, sure. Thank you, everyone, for participating. I'm going to go off the air now.